Okay. Good morning, everyone. I'm Ananya Daniel, your host for today's event, and I welcome you all to the day 3 of the Divergent series organized by IEDC MEC in collaboration with DevQuest, DSC, and Hack Club. It is a perfect opportunity for you to find out what your dream career is through this final wrap up of Divergent. So today we have with us Akhil Murali, a 2021 mechanical engineering pass out from St. Thomas College, Trivandrum, currently working in a German multinational company. So without any further ado, I call upon Akhil to start the session. Hello,
Hi,
Akhil.
Hi, how are you?
Hello. The stage is yours.
Yes, so thank you for keeping the intro short. That's why I like it. Anyway, mechanical engineering. I'm sure there will be people outside of mechanical engineering as well. So I'll just speak for a few minutes and then we'll go to a presentation and then you can ask questions at the end. Personally, I don't like presentations. It reminds me of the days of college where you have to stand in front of your professors and guess what you're going to say next. I don't like presentations, so if I can't make it well, I have to make it short. So I just decide to make a better presentation. You will see. It's more of doodles and a little bit of fun stuff to make this interesting. Anyway, mechanical engineering. There are good things about this branch and there are bad things about this branch. Good thing is that anything that you see around you is made by a mechanical engineer. This is a pair of scissors. This is designed by a mechanical engineer. The computer that you're on, it's designed by a mechanical engineer. Phone, it's designed by a mechanical engineer. Even a sharpener like this. So the idea or the concept of this is that no matter how much we go into the future, no matter how much we try to bring other branches like electronics and computer science into it, we still cannot go that change that other branches do have. For example, civil engineering is now kind of shifting towards bringing computer science and electronics into it to make it a little bit better. In mechanical engineering, you can make stuff better in a sense that if you want to design something, you can design it in CAD. But at the end of the day, you have to make a product. And as long as a product exists, there will always be a scope for mechanical engineers. The bad thing is that now we are at a phase where it's not peaking. It's like a growth stage and the growth is up there and now it's kind of going down. In a sense that not the branch is going down, but the technology in itself needs automation. So if you look at a factory, it's all mechanical engineering things, but 80% of it's automated. Nobody is working there. So if you need to get a good job, you need to be the person who automates that stuff. You need to make the person, you want to be that person who makes life easier for others. All right. So that is about kind of where we are headed. Now coming to jobs. If you look at electronics, electrical, and computer science, so for one job in the government sector, you have more than 50,000 jobs in the public sector for one job. So a computer science person might only be probably hired by the Ministry of Finance to make, financial transactional, some kind of software related to that. Or it might be used in defense research and development organization for guiding missiles. Small use cases. But if you go to, I live in Trivandrum, you can see Technopark right here. It's very big. Like hundreds and hundreds of companies are coming up each day, and there are lots of changes that are happening. It means for one job in the government sector, you have 50,000 jobs. So when you have 50,000 jobs, people will tend to neglect the government sector for it. Now, the next thing that is going to happen is, 1 minute. I'm having an audio issue. All right. Yeah, so that's the same with electrical and electronics as well. You have different manufacturers coming in from foreign companies doing investments here, any other places as well. But the thing about mechanical engineering is that most of the hardcore engineering stuff that you see here is already owned by the government. Railways is a big example, owned by the government. Nuclear, big example, owned by the government. Power sector, owned by the government. You don't have much diversity in this field when it comes to other companies that you can work on. And that said, there will be a Tata or a Mahindra that will hire you, and maybe some startups in and around Bangalore or Mumbai and Delhi. But primarily, the entire sector is focused on government-centric things, which are based on hard engineering. And therefore, for every job in the private sector, you have an equal job in the government sector. So that's a 1-to-1 ratio. So there are people who graduate out of mechanical engineering, and I'll suggest take write government exams. I wouldn't suggest that to computer science people or electronics people, but sit for government exams. It will be good. I think it can severely contribute to the India's progress as well, I guess. All right, so let's move into the presentation. I'll get straight to it. First slide itself. If you're going to work at the mechanical engineering field, this is the kind of place you're going to be working at. It will be filthy, it will be dirty, you will get your hands dirty. It is going to be like that. Jobs compared to computer science or any other stuff, you'll probably work in a 16-story, 17-story building with the MacBook in front of you, and you'll be typing code, you'll be designing things. Here it's kind of hard. If you're into design, 3D design, kind of like that, fine, you'll have to sit in front of the computer. Otherwise, a typical factory environment. Now I am exaggerating a bit here, but this is the thing, primarily the way in which you'll be making. For example, if you work at, I don't know, ISRO, you will be designing components, small components, which are for space. So you will need, machines like these. You will need CNC milling machines and those kind of stuff, which will be, you will be working in this kind of an environment. Some might not like it. Some will. I'm a person who loves this. There are people, there are different people. So you kind of have to make your own choice from there and move on. Salaries, that's a big thing. Mechanical engineering salaries, the salary graph is like this. It comes up and it kind of peaks and peaks and peaks. Computer science, it goes up like this. It's like going up as a vertical line. So I tend to see a lot of people who are changing domains to computer science, electronics, those kind of stuff. But I know one thing, you will be getting a lesser salary than your colleagues at the computer science department, because of the fact that it is a sector which increases innovation. Computer science, electronics, basically that. Mechanical engineering, there is innovation, but it is slightly dim. That's all. All right. So let's take this graph. Okay. So when you introduce something, it's called the introductory stage. This I think you'll learn this in economics or something. Then there is this growth stage where it's like immense growth. And then you'll reach a maturity. That is the maturity state of a product of an industry or anything like that. After that, either it goes to decline or it gets a renewal. Big example, 2005 and 6, there was actually wireless earbuds like these. I'm not wearing one. There'll be wireless earbuds. But nobody bought them. So there are a few manufacturers who made it, and then it kind of declined. But after 2015-16, when Apple introduced AirPods and those kind of stuff, the entire industry got renewed again. It's like slowly growing up. It's a typical example. If you look at mechanical engineering, introduction is when you had a need, when people needed to travel, when people wanted power in their homes, when people needed components and products that made their lives easier. Industrial revolution, that was the period. Growth stage is when you grow. That is, you build more factories, you put in more people, you make faster cars, you make better and efficient engines. Stuff like that is growth. And finally, you'll understand that there is a level to which that you can go. And that was around the 70s, 80s, and 90s for us. Now, we are in the declining stage of mechanical engineering. I wouldn't say declining, but that's how I put it. But it's called an automation era. We live in a world where if I'm the owner of a factory, I can control the factory, which is in Europe, sitting here through a computer. That is the power of automation. It brings down the cost. So nobody has to work there. You can just automate it. Robots will do the work for you. So when you're living in that kind of an era, you need to have specific skills which can solve the problem at hand. All right. And that will only lead to you getting a good career in this. Because when it's on a decline, for example, a lot of my friends who were with me in college between school, they have like 9.5 CGPA, but they still cannot get a job in this sector because they don't have the relevant skills that the industry needs. So that is a kind of a hard thing to digest, but this is how it is. All right. So the thing about engineering in this world is that you need to work smart, or you need to hire for efficiency. You need a person. If I am hiring a person, I need that person to have efficiency in mind. That means if I spend, 10 million a month on supplies and on the supply chain in the factory, maintaining stuff, production, all of those stuff, if I can get that to 9.5 million from 10, then that is a reduction of 500,000. So we need to be able to increase the efficiency. That is where the world is at now, at a stage of automation. Efficiency is key. And in an era like that, you need to work smart, not hard. If you design a thing in your home and say, I'm going to sell this to many people, that's kind of like hard work. If you solve a problem for a person who actually needs it and they pay money for you, is working smart. So you might ask, why do we need to automate? So it is like build machines that do the work while you rest. So if I'm an owner, I don't have to give money to 10 people. I don't have to, maybe there will be incidents. Maybe there are people who might do dumb stuff. Nobody is perfect. They will, in a way, do terrible things. They might not have 100% success rate in everything they do. So when you allow machines to do it, you only need to optimize via coding. Make a machine faster? Sure, write another piece of code. Simple, right? And so that is why there is a need for automation. Because if you go to any industry related to mechanical, there will be automation. It is an inevitable part of it. We have to deal with it. And you're going to have to make yourself presentable. So what can you do about it? This is how the industry is. So what do you need to do? And as a student in a college, your ability to think will be the most helpful thing. Your curiosity and your ability to think will lead you to more places. When someone teaches you, don't go and say, what is that? What is that? What is that? It doesn't work. Kind of like, how does this work? Why did that happen? Inquiry, the spirit of inquiry should always be within you. I'm a football fan. I remember something that a football manager said to a team. In a full court, the job of a coach is to take you through about 2/3 of the way, and the rest of the work has to be done by the team itself, not by the coach, right? So the way you do it is by your curiosity and with interacting with people that you kind of understand and get along with. If you want to have a good career, work on your skills and your curiosity to learn stuff. All right. Don't ask foolish questions. I mean, it's good to ask questions, but most of the things people ask are foolish. You need to have a relevant set of, it's called first principles thinking. If you take a battery and you tell, then how can you make it efficient? You divide the components into its single pieces. So you have an anode, a cathode, and an electrolyte. And then you take each component and make it better. This is not, if you take a battery and change its shape, it doesn't work. You won't get a better battery, right? So you need to think from first principles. You need to have that spirit of inquiry within you. That's all. Curiosity, skills. Skills in a sense that you're engineers, so you will go to the workshop, you will need to work on it. Welding, sheet metal works, all those kind of stuff, it will come in the future. Have that relevant set of skills. I would also say have the skills of design and engineering, and I'll come to that at the end. But when you have a curiosity, you tend to attract things that you really want, and through that you'll get a relevant set of skills which will propel you forward very well. So in a world which is crowded, there are, I don't know how many students are in your class, but there are 120 odd colleges in Kerala. There'll be 60 students in each class if every college has one class. So that's a huge number. Take that to whole of India, that's an extremely huge number. So you need to make yourself stand out in a crowd. So how do you stand out? This is the main problem. You are only studying for exams. Most people study, they just mug it up and they leave. That's it. This is wrong. You need to work on stuff. For example, I am a graduate. My year of studies are over. But let me show this. This is a heat sink. This is a mechanical heat sink. We are doing some validation testing on it. We are doing a project, personal project. So this is the way that you are learning, by doing stuff that interests you, not just learning for an exam, writing it all down and getting good marks. It won't help you. You will have, I think I have a friend, she has like 9.7 CGPA in mechanical engineering, and she has to work at, I think, an educational tech startup in Delhi or somewhere, because she doesn't have the relevant skills. And she's like severely underpaid to what a normal graduate would get, because you don't have that relevant set of skills. You don't learn for an exam. Free yourself from that shackle. You have to do it. Otherwise, it's kind of hard. I'll tell you another example. I have a friend in Bangalore. He has 240 students in its batch. About 20 got jobs in mechanical engineering, another 60 got jobs in IT. Rest are all jobless. So if you want to like stand out, you need to have that relevant set of skills. Moving on. Packaging makes a difference. You can sell a watermelon for $1 or a juice for $8, right? Packaging makes a difference. And just as you can see, you can make hundreds of cups with just a few watermelons, and you can sell it for a lot more for profit. So packaging means who you are as a person, because most companies, when they hire you, they don't look for, does this guy have the best knowledge? Can this guy do this kind of engineering well? Does he design well? No. There are 100 people in a company. And if there are 100 people in the company, if I hire this guy also, will he cope up with everyone? Will he interact well with everyone? Is he attuned to the company's culture? That's all. So you need to make yourself presentable technically as well as personally. So who you are does make a difference. So work on that. Now, the earlier portfolio for a resume was, I have worked here, I have studied from this prestigious college, I know these stuff, this is what I'm going to do. This doesn't work. Today, what you need to do is tell them, this is the problem that you have. There is a solution for it. If you hire me, I can provide that solution. If you do that, it's there. You acknowledge that there is a problem. You research enough about the company and understand that they are facing this issue. You're making yourself presentable with a clear insight of it. And number three, when you have technically prepared yourself well for it, then you have a good success of it. This I have studied from IIT doesn't cut it anymore. I'm sorry, it doesn't cut it anymore. You have to work on it. You have to make the other person's needs in tune. All right. So what do you need to do? Practice. What to practice? We'll come to that at the end. So practice in a sense that you need to make things relevant. You need to make things easier. You need to make things better for the other person. Nobody will hire you just because they have to give a job to give away. They hire you to solve a specific problem, right? So, like I said, intelligence, abilities, and a desire to reach their potential. That's what defines you as a person. You need to be able, number one, you need to have good convincing skills. And number two, you need to have that desire, because that desire will help you anywhere. So for example, this is the rear subframe assembly. Well, I'm going a little bit technical here. This is the rear subframe assembly of 1960s or 17s Canadian American. There's a racing series called the Canadian American series. It was back in 1970s. So this is the rear subframe assembly of a racing car from there. As you can see, that's the rear subframe. There is an engine here. It is bolted to the transmission at the rear. The rear wing is a part of this assembly. You have the rear suspension arms, the differential, it's all inside one package. You can see the bolt-on mechanism in the front. This is a V8 engine. It will produce around 1000 horsepower. If I wanted to see this 10 years ago or 20 years ago, I would have to go to a museum in some other country. Now I have the luxury of seeing these technical drawings here. So you don't need to have, I'll tell you one more thing. If you are a computer science student, you have that ability to code. You buy a laptop and you can write code. Mechanical engineers don't have that, because now because you need tools to work with. Unless you have a fully fledged workshop at home, there is no use to practice your skills. Because a computer science student, he can just code for 2 hours every day and he'll become a better person. Mechanical engineers don't have that. You need to have a big workshop in your home for that. And most people don't have that. So what you can do is look at technical stuff, look at stuff like this, understand, and try to make things a bit more interesting. So this is something. So what can I understand from this? I can see how the intake system works. I can see how they made the suspension geometry better. I can see how the brakes are quite small for the size of the car. I can see that what aerodynamics and the layout has to be given so that, the aerodynamics has to be great. So I can understand what the layout should be. Stuff like that. So this is something that you could not do before. And I suggest reading technical papers, drawing, CAD files, stuff like that. It'll help you a lot. Moving on. In the past, the engineering school was the only way you could learn. Now it's not that. You can learn it. I would suggest YouTube University. YouTube University is the best. for learning anything related to mechanical engineering. I think YouTube has really amazing technical stuff. If you go dig a little bit deeper from those average channels that you watch, you'll find really, really, really good stuff. Systems about heat pumps, heat exchangers, stuff like many beautiful stuff. Electric cars, battery assembly, all those stuff. It's really, really amazing. This is how the world is going now. Make use of it, because we are at a point where resources are infinite and most people aren't using it. And if you're not succeeding in what you want today, you will never would, because the resources that you need are right in front of you. Make use of it. The another thing about mechanical engineering is that things will not be the same. You have to collect information from different parts. For example, if you're into high-end cars or motorcycles, they'll be using components from aerospace. If you take probably a high-end BMW car, they will have certain components which are taken from their division or from their partners from the aerospace division. So because of that, you need to have multiple set of skills. You need to be good in aerospace up to a certain extent. You need to be good in automotive. You need to be good at designing that thing and making that component stick or making it an integral part of this new system. So there are companies which have both divisions. Kawasaki is an example. They have they make jet engines and they make bikes. So they shift components between the two. So you need to have a relevant set of skills and knowledge about both industries, because today it is not about I can design well or I can code well or I can do stuff in about manufacturing. I can set up a plant, but you need to know everything, and that is the only way you're going to succeed. You need to collect, and then you have to have an ability to connect those all of those together and make it perfect. And that is going to make you you. Moving on. Knowledge that you got somewhere. Maybe you worked at 10 places. You worked at this company, this company, this company, there. You have all these amazing stuff that you have. Maybe next is a company that you're going to start yourself. You might be an entrepreneur in the future. So you can take all those things and put it to where you want. You can take an efficiency increasing technique that you found in probably a jet engine. If you worked at something like let's say a manufacturer, let's say you worked at Boeing or Airbus. You take some inspiration that you found there, you might put it into your own company. So you need to have that skill of putting things together. Right. So this is the new resume: building in public and proof of your work. What proof of work? Just open up your computer, look at a technical drawing, write a CAD file. Your light is not working, try to fix it yourself in a car. Stuff like that, small, simple stuff like that, but it will definitely help you a lot. I am a mechanical engineer. I still like root my phone. I disable all location tracking stuff. All those kinds of stuff. I go into all the details here. I'm not a computer science by any means, but I do that. Now, let's say if I'm striking with a conversation with someone, I can say, I just coded some things and I just got my phone of all these stuff. My phone is now clean. So he's like, oh, this guy has skills in computer science as well as mechanical. He should be a good hire. So you can never expect something. Maybe you're with someone, he might be your new recruiter. You never know. And so this is the new resume: proof of work and building in public. Now, by building in public, I mean use LinkedIn to your advantage. Put different posts out. Make yourself heard. Make yourself heard by more people. I think that is a very important thing to do, because if don't make yourself heard, then you're irrelevant. Nobody knows you. Nobody will come to you and say, I have a job, do you want it? So you need to make yourself go out there. Now, another thing is So think of a college as a factory. Every student is learning the same thing and going out. So if you want to stand out, you need to have a specific skill, because if the college can train one person, a college can train many people. So if you have 100 students, 100 students know the same thing. But what should make you different is that ability to know something different from the other person. I think if you go to Hyderabad, Bangalore, and Chennai, if you go to a club or something, you will find these people who are coming in. They're not actually celebrities, they're actually engineers. And they are treated like a rock stars there. And it's because they have a specific set of skills, which are, for example, one guy might be a good website designer. He goes somewhere, 10 people will come to him and say, I want this website designed, I'll give you 10 lakhs. Another person is like, I'll design this, I'll give you 12 lakhs. So you need to have that specific knowledge, because specific knowledge cannot be automated. You take 20 years into the future, the teacher at college will probably be a robot, because he's teaching the same thing again and again. What you need to have is a specific skill, and specific skills cannot be automated. In a world of automation, you need to make yourself stand out, and this is how you do it. So what should you learn? So these are the stuff that are relevant and you should do. You should pay extra time to it. 3D design and modeling. I'm not going to suggest a specific app for it. Do or take an app which you're good at doing. Understand how it works. There are hundreds of apps. I am not suggesting one. Many industries use different apps. The app used by one company will be different from another. So it's up to you. Do what you find like it's good, but it has an industry standard of its own. Simulations and analysis. Let's say you take a phone, there will be a person who is trying to bend this. So the structure of this phone needs to be intact. So in order to make that intact, there should be structural analysis should be done. So you take the hard shell of a phone and you do structural analysis. There is a wind turbine that is blowing air. Air comes in and you see how pressure differences are there, how things are starting to pan out. All those stuff are done using analysis and simulation. Because today, 80% of the thing is done on a computer, and the last 20% is actually building it. Everything is optimized here in the hope that it will work there. It will. Earlier, you have to build prototype after prototype after prototype in order to get a final product. Now it's not that. So you need to know modeling and simulations. Next, basic concepts of electrical and computer science. This is a given thing. A bike cannot start without turning the ignition key and without power from the battery. Mechanical engineering cannot stand on its own without electronics and computer science. Learn the basics of it. I am not saying go develop a website. I'm not saying go develop an app. Learn the basics, learn how code works. That's it. Product development. You need to understand how a product works. You need to understand how it is developed. So for example, if I make a dream, I'm a motorcycle fan. So if I make a dream motorcycle of mine, I'll put in the best parts. I'll do all of this. But the problem is the cost will be around 10 lakhs. Now, who will take the money of 10 lakhs and put it out there? Nobody will, right? So you need to make sacrifices. Let's say if you make a product for 2 lakhs, how will people buy that stuff? If you build a product for 50,000, how many people will buy that stuff? What is the target market? So that are all the things that are in progress. So that is the thing in product development. Reading and writing technical papers, basic, simple, read as much as you can. Publications are important if you are doing engineering. If you are getting papers published, it's very advantageous. So understand papers, try to write a few as well. Trigonometry and calculus, basic thing. You have to learn it in order to survive in the subjects. It's a must and a norm. Statistics, not statistics as such, but you need to be able to understand numbers. You need to understand how numbers work. If you get 100 numbers on an Excel sheet, you have to make the correct decision based on it. And then the last is optimization skills. If a raw material goes into a factory and comes out after 1 hour, how can you reduce that time to 50 minutes or 45 minutes? So stuff like that, you can do it easy. So this is how this is an example of how the great car company Porsche actually started. It's just a wood shop, just a carpentry shop in Austria, and this is where they started Porsche, just on a sheet of paper. And I advise you, if you have the skills relevant, if you have the knowledge, don't wait for anything. Go make your own dream come true. Start your entrepreneurial journey. It'll be amazing. Jobs for you. What will be the target jobs? You will be a design engineer. You'll be designing stuff, laptops. You will be designing phones. You'll be designing cars. You will be designing equipments, stuff like that. Factory planning. There's an entrance to a factory, there's an exit to a factory, but what happens in between has to be planned accordingly. You can't put the engine shop near the paint shop, or you don't put the final assembly near the parts area. So yes, a planning have to be there. So that's something that you can work on. Nuclear engineering, same story. You need very dedicated engineers for that. Military services, you will be probably be designing the next BrahMos missile. You'll be probably designing the next tanks, stuff like that. Engineering consultancy. My friend actually has an engineering consultancy firm in Mumbai, I think. He does a lot of projects for engineering. He's just 25 or something. Brilliant guy. You can start your own consultancy. Just give your knowledge to other people and let them pay money for it. Aerospace, typical, everybody is sending rockets to space now. Everybody's in the space race. Can be a part of it. Automotive, I don't need to tell you much. Agro equipment, that's another thing. Now, let's say around less than 1% of America does agriculture. People, less than 1% of people. But everything is automated. Machines, trucks, big equipment are used. So you can work in those kind of areas, which can, I mean, at the end of the day, you have to eat. If you have to eat, you need food. So that agriculture is never going to die, and that's an evergreen industry that you can work for. So it's all about how you can make yourself presentable. It's all about how you have that ability to think. This is a picture in 1970s, I guess. This is how the Kawasaki motorcycles were designed. It is the design facility in Europe. So that you can see drafters and you can see papers, they're doing technical drawings. All right, so higher studies. If you want to do MTech, it's good. There will be specific jobs which require you to do a master's degree. So you can do that. However, most jobs will be okay with a bachelor's degree. There will be some jobs, especially abroad, which requires you to do a PhD. So think and adapt to that depending on the needs. Naval architecture is another, the waterways are the trade routes of this world now. So we need bigger ships, we need better ships, we need smaller ships to help those better ships. And as long as those things come into play, Navy services, example, all those things, if you have fan of boats, ships, those kinds of, it's a good field for you. MDes. So this is design basically. So you can design, it's more of design. I wouldn't say it's engineering, but it's more of design, but it's a good career choice. There are a lot of people who are going into design. Let's say you're a fan of electronics. You can design phones or design gadgets, design laptops, stuff like that. There are some programs which are MTech and PhD integrated. That's why you put an and there. This is like 2 years of MTech and the rest of the time you do a PhD. So within 5 years, you'll have a doctorate in front of your name. So that is something that you can look into. An MBA, This is more of a management style. So you won't need to do the labor hard work that I told you before. If you have an MBA, you'll be probably working in the management field, trying to manage stuff, getting capital allocated, stuff like that. And then you can always do your MS abroad, especially I would suggest Europe. US is also nice. Singapore, Australia, somewhere where you find that you have get into a good university with a relevant recognition, and you can have a really good career. So just explore yourself, make your brain pop, make yourself presentable, have the relevant skills, know about the industry. And from that, it's just go in and do your work. That's all. You're here. This is something that you could not change before, but the future, you can always change it. You can always change, you can always make an impact, and it's up to you and yours. The journey of 1,000 miles starts with a single step, right? So today you can start. That's it. Thank you.
That was a very insightful session. All right. I'm pretty sure everyone here had a great time understanding and grasping the mechanics of this field. And let's now have like a short Q&A session. If there are any doubts, you can drop it in the chat box, or you can like unmute yourself and feel free to ask directly to Akhil. So we can wait for the questions. You can ask anything, any doubts that you have, you can ask.
If you don't want to ask, chat box is available. Come on, guys, I want questions. I think nobody has questions.
Yeah, everyone understood everything.
Actually, I have a question.
Yeah, sure. Go on.
So I was wondering, like, you talked about developing extra skills other than the one taught in academics, right? So me personally, I'm interested in like IoT and like building stuff generally. So I was wondering, like, when you're setting out to build a project, right? You have all these requirements. You need electrical components, you need mechanical components. So with regards to mechanical components, the techniques used, how do you start for like DIY projects? Any particular resource, any particular point where you have personally started, or any particular thing that you would recommend others to start with us?
All right. It's funny you mentioned this. Back when I was in 12th, you remember the old Contessa cars? You remember
Yes.
the Contessa? Yeah. So we actually, me and a friend of mine bought a shell of that car. No engine, nothing, completely from the scrapyard. We bought it home, and then we started to make this into an electric car.
Wow. Okay.
It didn't work out. It didn't work out. We didn't have money. So like I did a very big thing. It didn't work. I'll show you something. Okay. Wait. Let me just pull that up.
Yeah,
we
sure.
did something else. So after that, I understood the problem that I aimed too much. And so,
Are you sharing your screen?
yeah, no. I'm not sharing my screen. I'm opening something so that I can show you that. Okay, so this is something that I purchased from the scrapyard.
Oh.
This is something that I purchased from the scrapyard. Okay, this is something that I purchased. Within about 3 months, it became something like, I'll show you. it became something like this.
Wow.
Wow.
Pretty cool.
Yeah. So it's your ability to do stuff. I didn't know how to paint. We didn't know how to fix stuff. I didn't even know the part that was going to be used, but we still did it. There's a few other people as well. But your ability to do something is even more important. I would say your curiosity. I didn't, like, for example, this was a big failure. I'll tell you why. If you take a bike apart, you will see a frame, right? There's a frame on which everything is mounted. In a scooter like this, there is no frame. Your engine is directly mounted to the body.
Oh, I see. Okay.
And the wheel is mounted to the engine.
Wow. Okay.
So if I wanted to put the electric stuff into, I want to make this an electric vehicle. So I wanted to put that electric stuff in there. I need to remove the engine. And if I remove the engine, the wheel comes off. I don't have a place to put the wheel. So this I understood very late.
Okay.
We finished this thing and we understood that we couldn't make this work.
Ouch.
It's stuff like this. You will only learn something when you're into it. So like, I wouldn't say do this kind of stuff. I was an idiot at this point. But small projects, like there you can get conversion kits for example, electric cycles. You can get a conversion kit for an electric cycle. Just buy a conversion kit. It's just 5,000 rupees. I'm not saying it's affordable, but just put it in your bicycle. Just take out those wheels, put stuff in. Simple. It's not complicated. Just look at some YouTube videos. There will be some guy who's making. Just don't do anything. Just make a remote controlled car. You'll get parts for it. You'll get many help for this online. Just make simple stuff. Just start with very, very simple stuff. That's just it. For example, it's IoT. Just you have a breadboard, stuff like that at home, Aditya?
Yes.
Breadboard stuff. I have a few here. Breadboard, some motors, some actuators, like all those stuff.
Definitely. Mm-hmm.
Buy a kit like that. Go look for online tutorials. By the time you binge watch a season of something on Netflix, you will probably have a good. Yeah, just do like that. There's nothing else into it. It's not something that is teachable. I would say it's something that you have to have it on your own. Yeah. Somebody asked a question. What software should we learn for skills? I would suggest all of you who are students, get your ID card scanned, have the Autodesk subscription, the Autodesk. So I can share my screen. Yeah. Sorry, I was searching for helical gears. Autodesk. So Autodesk is a company which makes softwares for engineers. And for students, if you scan your ID card, they will give you, for example, product design and manufacturing, top products. So they will give you free. Everything in this is completely free. Just get that. This is like, $2,800 a year. It's like really expensive. But for students, it's completely free. You will get Fusion 360, AutoCAD, all those stuff. You will get this for free. Go and do this. For software that is related to design and manufacture, stuff like that, I would suggest ANSYS as well. In SYS, ANSYS is for completely simulation-based stuff. You have a student package here that is also free. Go do all those testing. You will find stuff like this. Material science, acoustic simulation, edit. It's all there. Additive, for example, additive. Something that is new in mechanical engineering is 3D printing, right? So you can 3D print your own stuff. So additive manufacturing, there's another software for that. So there's something in there for everyone. Just go to these websites, there's another thing called Hypermesh. Hypermesh is another, this is finite element modeling. This is used for simulations in wind turbines, high-rise buildings, stuff like that. This is a very good solution for it. I think the page is not loading yet. So you can see these meshes, right? Can you see in this picture these meshes? Aditya?
Yes. We can see
So these meshes. So these are these finite elements. You are making a component and you're dividing it into smaller components. And with these smaller components, you are computing the pressure, the velocity, all those stuff in all those single components. And the total will be the sum of all these. So for example, this is another one. This is where fluid is going through the fluid. So you can see there are lots of triangles here. That means that there is a turbulent flow here, right around here. And there's more of a smooth flow on the sides. So this is how you optimize and design stuff like that. Just go through all this stuff. You'll get lots of interesting stuff there. I wouldn't suggest a software. There are a lot of softwares. Okay, so you put the.
Yes, good. I put the links in the.
Thanks, man. Thanks. Do startups have any scope in dual mechanics? Yes. Go around Bangalore, you will find amazing startups. Drone manufacturing, electric scooter manufacturing. Then there are, these scooters that small, like the kids use, stuff like that. There's hundreds of small companies, but I don't know if they'll be able to sustain that. For example, most startups do die after a few years. 90% of startups actually die. If you don't know, 90% of startups die, 10% only work. The things that you do work are pretty good. So for example, Ola is a company that has now a scooter now. It's an electric scooter. Now they have started production of their second plant in Hosur near Bangalore. They started out as a service company. Now they're doing into products. So startups do have a scope. There is a company that I saw. I don't remember. Let me see if I can share the screen and show you. There's this company called Tesla, not the Tesla, TEZLA, stuff like that. Tesla, I think it's in Cochin. Sorry. Yeah, Tesla. This is kind of like that. Tesla. This is a startup in. You see, they manufacture bicycles like these. So this is a startup. This is made by some few Malayalis in Cochin. They wanted to go some places and they told like, let's design it on our own. Something like this, right? It's called Tesla. Like do search for this stuff. You will find some amazing stuff from their website. There are lots of people who are buying it. I've seen a few celebrities endorsing this as well. So yeah, that's your answer for you. There are lots of people who are there. I would suggest work at a startup in your early career from 22, 23 all the way to 27, because after that you want a stable job in hand, not a job that you might lose in the future. So work at a startup in your younger years. It will definitely be good for you. If you're planning to start one, go for it. Government incentives are its highest. People want more products. People want cheaper products. India is a big country. They want to travel. So, and for example, I'll tell you, 60 to 70% of India's industry is basically services. Infosys, TCS, Wipros, all those stuff. Only 10 to 15% or about 20% is the manufacturing sector. And most of those manufacturing sectors are people that are coming. For example, Mercedes-Benz comes in, set up a plant here, exports. Kia comes in, set up a plant, exports. Hyundai, same thing. We don't have much of our own. And Indians tend to prefer Indian stuff. So if you are going to have one, go ahead. It's really nice.
Hi, my name is Alex. I just wanted to ask, can you hear me?
Yes, you're audible. Yeah.
I just wanted to ask, what is the scope of this Hyperloop project in India? Let's say India.
Very good question. Hyperloop, for people who don't know, is basically you take a fan, stator, it has a stator and it has a rotor. So the rotor rotates inside the stator. So what if you could take this stator and you put this linearly, like a circle, and you put this linearly, appear a long range of magnets, and you make the thing like roll over this thing in a levitating manner. So Hyperloop is a very good concept. It is really nice. It's an evacuated chamber inside which you travel. The problem is cost, first of all, because we still are at a time in this world, in India, where most people cannot even afford a flight ticket. And so when you're introducing a mode of transport which is faster, but it's also might be more expensive than flight travel, the people who are going to use it will be extremely low. Why are metro rates so cheap? Kochi metro has 10 rupees minimum, right? Something like that. Why is it 10 rupees? Why is it not 20 rupees or 30 rupees? Because more people use it. And when you put a heavy cost intensive project into this world, you need to get money from the people who are actually going to use it. And so the tickets are going to be really, really expensive. And Hyperloops are only good for long distance. Bangalore, Delhi, Mumbai, Chennai, stuff like that. I'm sure it might happen. Don't look at it for another 5 years. Not going to happen. In India, I don't think so. Other places, probably. Yes, outside countries, China, US, Europe. They'll have a green flag. Some other question. Which country has the best scope for mechanical engineers? Europe has always been the Germany, France, UK, stuff like that. Look at manufacturers. Mini, Rolls-Royce, Land Rover, Jaguar, UK, Mercedes, Audi, Porsche, Germany, Bugatti, France, Peugeot, France, Italy, you have Ducatis, Fiats. There are American as well, Ford and Chrysler, stuff like that. I think the problem now is it's being spread out now. Now, there was hyper-localization before in the European area. Now, because of startups coming, electric vehicles coming, now it's all about Silicon Valley now. And that Silicon Valley is slowly transitioning. Now, the thing is, it doesn't matter. There will be some, it depends on where you are, first of all. If you want to go into a legacy manufacturer and have a good, stable job, go for Europe, I would say, or US. If it's not, if you want to, if you go to Bangalore, there are lots of companies that are building good, cool stuff. So in India, I would say the scope is less, but it will get better. That's all. It won't be at its best. If you want instant money, if you want instant jobs, try moving out of India. That is better. Don't go for smaller countries, Singapore, Portugal, Spain. Like they don't have much industry. Go for Germany, France, UK, those kind of stuff. That'll be better. Scope for engineers in army. Good question. We have some rogue neighbors called China and Pakistan. So army spending is going to only increase in the future. That includes upgrading of infrastructure, missiles, anything like that. I would say all engineers, electronics, electrical, computer sciences, go for the army. You'll get good jobs there because first of all, it's a national security thing. So nobody's going to hire a German guy and give him Indian knowledge. So Indians have a good in the army. They have a good real security there. You have to build faster missiles. You have to build faster jets. You have to build faster tanks. I think at the end, it's not something that you can do it softly. Now it's all about drones and those kind of stuff. Drones are made by mechanical engineers. Just I'll give you an exercise for today. Go and learn how drones work. It's very fascinating. You have these 4 blades and you're kind of changing the speed between these blades in order to make it stable. It's kind of nice. Try and find out. It's really nice. Army offers very good stuff. Anything that is related to the army, if it's gun manufacturing, we are still importing guns from Russia. We are still importing tanks from Russia. We are still importing BrahMos missile is a collaboration between Russia and India. So you need, for example, I think in UP or Bihar somewhere, there is a defense industrial complex that is coming up for the manufacturing. Then they are turning gun manufacturing into India as well for the army. So the future is bright in the army if you can get into the technical level. Most people, they go into officer level. If you can go into military engineering, it's nice. It's highly recommended.
That's an question. Yeah.
Best for car designing? Well, that depends. Probably it depends on design. Is something that is very subjective. Something that I like might not be something that you like. I'm a person who likes angular stuff. So cars with sharp, angular, but some other people might like curves much more. So it depends. Design is very subjective. I can't really give you a good answer. So Gyan, Krishna, download Blender and start designing on your own. That is your best advice that I can give. Take some, or just say you'll get some CAD files of cars probably in online. Just take them, design stuff on your own. Like I said, proof of work is important. If I hire you, what am I paying for? Like you can like put it in your resume. Just give a website link, just a Google Drive link or something of the projects that you've done. Give it in your email, and you'll see amazing photos or something that you have designed. That's an added advantage. You'll get through the technical interview without even having to sit in it. So proof of work is important. Make yourself heard. Study Blender. It'll help. I know that Blender is more of a movie and visual effects thing, but if you're into designing, Blender is really nice. Yes.
Yeah, okay. So I guess it's time to wrap up. I thank you, Akhil, for being with us here today. And on behalf of the Divergent team and our wonderful audience, I thank you so much. I hope everyone had a great time today. Thank you for joining. Bye-bye. You can start leaving.
Thank you, guys.
Thank you so much.
Bye-bye. Thanks a lot, Akhil, by the way.
Thank you. Thank you, everyone. Have a great
Really
day.
nice
Just
to connect
contact
with you.
Ananya if you want my contact number or anything like that. So, yeah.
If anyone has any more doubts or want to personally ask anything, you all can contact us and we'll connect you to him. To Akhil. Thank you so much, guys. Thank you.
Thank you. Bye-bye.
What a wonderful audience.